So my name is Matt, and I guess for the last 5 or 6 years, I've been doing production distributed systems for enterprise companies as well as startups. Just to give you an idea of who I am, what I've done, here's a general overview of some of the companies I've worked for or worked with. The main project I actually did with distributed computing was actually building a single pane of glass for all of cloud, which I think is pretty interesting based on, everybody's here because we're kind of focused around cloud. I was working with AWS, Azure, Alibaba's cloud, IBM's cloud when it was still Bluemix, Google Cloud, plus if you want to count Rackspace before they went to like service oriented, I worked with them a lot as well. It's kind of making a single API and actually bringing all that data into one actual platform where if you had a multi-cloud environment, you can control it all from one place. So before I get into this, because I really hate slides, I'm kind of anti-slides, but I wanted to try and be traditional. Does anyone currently use microservices? We're going to get into that, trust me. Because I will tell you, when I started down that journey years ago, I did it wrong. Most people do it wrong. It's a very difficult problem to solve. But pretty much at the end of the day, you're actually doing separation of concerns. One of the main things I actually learned from actually going from like a monolithic architecture to a microservice architecture was before you write any code, you should probably start whiteboarding and having meetings and discussing with not only the business side, but the operation side and the development side before you even write one line of code. Because that's normally where people start to make mistakes in the very beginning. And so this talk's actually going to be focused. It's going to look a lot like it's microservice talk because a lot of people do it wrong. And I think a lot of people don't need to go that route because most people don't get to that scale. Any questions so far? Sweet. So this is a high-level overview of just the application level of what a very small application would look like if you broke it down into a microservice-based architecture. You'll see you have 3 services, multiple instances there, some sort of gateway to actually route requests as they come in to those services. And then this is a bit more complicated of what that small application would actually look like if you throw in all the operations that are actually involved in actually executing and running that system in a production environment. So you're going to have your source control, your CI/CD system if you're lucky. Everybody likes to say they have CI/CD and most people don't. There's only a few companies I've actually seen where you write code and actually goes into production in the same day. Exception tracking, there's Rollbar, there's Sentry, there's a couple other companies that do that. So when exceptions occur either on the JavaScript side, whatever framework you're using, or on the backend side, you actually have some report of that so you can actually build bugs and feature requests from that and actually improve your quality of your software. Metrics to see when requests are failing, things like that. You can actually set thresholds on and alerts with PagerDuty and things for your operations people that can actually see why did this occur, what do we have to do to resolve it, things like that. Orchestration, I'm going to go ahead and just say, bite the bullet, Mesos is dead, Swarm is dead, everybody's gone to Kubernetes or serverless. I have seen things like Meso orchestrated Kubernetes clusters, which is interesting, but a little overcomplicated. And I think, and this is my personal belief, that you need some sort of message queue or broker to have true microservice architecture. Otherwise, you come up with this, and we'll go into this in the next couple of slides, distributed monolith, where everything, and it actually, it's interesting that the space system or spaceship talk earlier with the IoT kind of went through loosely coupled and resiliency, because it kind of actually all comes back into how to actually build a system properly. And as well as your logs. So when you have all your services running everywhere, you need actual logs where you can actually get useful information out of it to troubleshoot and figure out where the problem is. In this actual diagram, you'll see that there's actually 2 instances of Postgres and an instance of MongoDB. Your database backend layer shouldn't really rely on a single database. It should use the best database for whatever the service is doing. All right.
So just kind of talked about this a little bit. You do have the distributed monolith problem where you have service A, it talks to service B talks to service C, and if service C goes down, service A never gets back to whoever's actually calling it, and then your entire system kind of falls over, which ends up breaking SLAs that your companies have, has downtime for your end users, and you end up, and I've actually done this, having to re-architect the entire application from the ground up, which sucks. Do any of you work at startups? Wow. So I'm a transplant from Austin. Everything's startup there. It's a little different environment. You got one over there in the back. So everybody's here either, I guess, government, enterprise level, or somewhere in the middle. Sweet. So my recommendation is you should probably actually just stick with a monolithic design unless you're at that scale where it actually makes sense to actually break down your application and scale out the actual pieces that need to be scaled out, because at the end of the day, you're actually just making a huge headache for yourself. So this is example one. This is actually before Kubernetes had any kind of tooling. I built this dashboard for our cluster. So you'll see there's 212 pods. So there's about 60 microservices per environment, which are in different namespaces here. And all of these were actually interconnected at some point. So the authentication went through an application gateway. So all of our authentication, authorization went through there. But after that, so if we see at the top here, the alerting would have to talk to the user database, and the user database would have to return like an email address, which then would have to talk to like an email template system to get the template for the email, and then an email service to actually send an email out. And so if any one of those components actually failed, the entire system just fell down, which is great if you love fighting fires all day and not creating things, but not something I enjoy. More visual representation of that here, where you'll see all these lines kind of interconnected. Has anyone ever built a system like this or seen a system at the places you work? Yeah, this is why everybody hates microservices right here. It can be good if it's done right, but it's very, very difficult to do. So distributed computing is hard is the end of what I want to say about microservices, unless you guys have any questions. So what questions do you guys have so far? Oh, we got one. I do use Prometheus. Debatable. I come from a different time. I come from building Nagios and Zabbix from hand and doing monitoring from hand and from the system side of it. So I've used Prometheus now for 3 years. We use Prometheus now where I'm at, and so for you, Emily, we could probably get together later. I work at IBM Cloud. We could talk about those cloud functions. So we use the metrics there to actually build dashboards and graphs. Those are actual more components. So if we go over here before we go to terminal, you also have to deploy charts so you can actually see when things are down. So like here, we're actually seeing 500 errors and smoke test errors and when they're happening, where they're happening, so we can actually diagnose problems visually. We also have to have logs. So I'm not a fan of elk stack, if anybody's going to ask that question, but that's kind of the go-to for logging outside of, I guess, Sumo Logic and a couple other companies in that space. Yeah, that's what I have to say about Prometheus. Any other questions before we kind of dig down into actually code and like deploying stuff? And no, sweet. So I'm going to pull up the terminal. I'm going to make that bigger. Let me know when it's good. Okay. So we'll start with microservices, and then we'll move on to like why you should probably actually just use a monolith. So I was bored and I wrote this application. And then I set up Kubernetes, and I set up Jenkins, and I set up a CI/CD pipeline. So we're going to go through the entire software delivery cycle since apparently a couple speakers fell out and we have more time. So first things first, when you have your
application, you're breaking it down in microservices, the most common pattern to use is to have a gateway where all of your actual requests come in, whether that be a gateway you write or a gateway like provided by Amazon or one of the cloud providers that actually provide that for you. To make sure everybody's comfortable, I wrote it in 4 different languages. So we have Golang here for our API gateway. This is just a glorified reverse proxy. It's more lightweight than Nginx or HA proxy. So here, we're really just taking the request and we're using a built-in package that Golang provides to actually do a reverse proxy. And you'll see all the routes here and then the actual service that it's actually being routed to. That's pretty simple, just logs and reverse proxies. So that sits out in front of all of our services. And then all of our other services here, in this case, it's a mock blog. So we have posts. This is in Python. It's just a Flask RESTful API. It does gets, posts, puts, deletes, nothing complicated. Just kind of separates our concerns of all of our services. So this service just handles everything post related. And then we have tags. So if anyone's ever touched WordPress, this is a HAPI Node.js application. Same thing, we set up our routes. We do some mock handling of the requests and responses, just so we can actually test it when we do the deployment. So I'm using Minikube locally to actually do the deployment. Right now, we have no pods. Pod is a term they use in Kubernetes to describe a container or a collection of containers, depending how you actually configure it. And I guess we do have one more service. We have the category service, and this is just because I love Perl and nobody else does, so I'm going to make you look at it. So this is a Linux thing. If you ever did Linux like 10 years ago, everything was Perl. Same thing, take requests, do mock responses. Nothing complicated, just more subs and curly braces than everybody's used to. It's not that ugly. Side note, I worked at a company once that their entire billing software was a 10,000 line Perl script. And it worked for 15 years. One file, not broken up. That's why people hate Perl. So with that, when you get to microservices, one, you have to write all the services. They have to be separate services. They have to do their one thing, whatever they're good at. And then you have to configure those services. And then after you configure those services, we'll go through the configuration. You have to work on writing tests for each service, deploying each service, monitoring each service separately. So from that point of view, you've just made a whole bunch more work for you. So in the configuration, we are going to have services and deployments. I'm not going to go too in-depth into Kubernetes terminology, but service is pretty much proxy to a collection of containers and based on ports, and deployments just make sure that a certain number of containers are running for a given Docker image. And so all of our services are configured here. And this will actually set up Kubernetes to actually deploy all of the code to our cluster, whether that be locally, Amazon, Azure, wherever you need it to actually be. So this actually handles that. But before we actually do that, we're going to, instead of actually deploying manually, we'll use a pipeline to actually deploy it. So you can see some other pieces that will be necessary when you actually make the migration or if you have already in that situation. So we have deploy services. This is just pretty much a pub sub on SQS that listens for an event to occur based off a Jenkins job that's we're going to run in a second. So
it work? It works. Cool. So we're going to build this project. This will actually take the GitHub, pull it, set up all of the tests that I have written for this application, and then send a message to SQS, which is then being queried locally with a long pull to actually deploy all of that configuration we just looked at to my local Kubernetes cluster. So we could watch Jenkins build, or I could source the environment and run that again, which is fine. So it got the message from SQS. It's now building all the images. These images are actually being built and stored on Minikube. So you can set up Minikube as your actual Docker image repository environment. And then it's going to actually deploy all that configuration to that cluster. So that was a lot of things right there. I know we just kind of did everything from application development to deployment. We'll see here that it is deployed. Questions so far on all the different pieces and components that we've gone through just on the microservice side? No, no questions. Quiet crowd. All right. Well, that is the microservice section. We're going to go to monolith. I was hoping there would be more questions, but that's all right. What was it that made those microservices? What made them actually microservices is because they have a bounded context on what they actually perform actions on. So in this case, it was a blog. We had categories, as you can see here, categories, posts, and tags. So each service is completely separate from each other service. Doesn't know about any other service. It only cares about tags. Doesn't know if a tag for a given post, if that post exists. Doesn't care. It just knows there's tags with this UUID somewhere, and at some point, depending on whatever application pattern you're going to use, like if you're going to use CQRS or some sort of aggregation into a single document to actually just return JSON, it doesn't care. It just says, I know that there's this tag for this UUID that I was provided. And same with all the other services, except for their different contexts. So why I think everybody should probably stick with monolithic applications is I come from a place where I like to use the KISS methodology. Just keep it simple, stupid. Because once you go down that route, it gets really complicated really fast. And so I've done this with teams all over the world. Ukraine, India, Colombia, a couple other teams, different countries, and that's going from monolith to microservice. I've done the entire migration, and it's never a fun or easy time. Because at that point, and now everybody, and you guys probably have experienced this yourself, everybody expects a developer to also be an operations expert and a Linux expert and your DevOps person. There's no longer really room for specialists in tech anymore. At least that's my opinion. Nowadays, everybody has to be a generalist and has to be able to do everything all the time, which, yeah, it's more fun, I think. You're not just pumping out code. And some of the pros that you get from microservice applications, you can actually get from monoliths. You can actually just scale out monolith, and you can scale it out on 1, 2 machines without any issues. The reason people go down microservices is to actually narrow down, hey, I know that only this section of my application gets hammered all the time. And so with that, you don't have to take the entire application, break it all apart, and then have a billion different pieces. You take that one piece, and what they call that the strangle method, and you make that its own application. You integrate it, probably depending on your volume. RabbitMQ is probably good, ActiveMQ. If you have to actually go distributed, Kafka is kind of the go-to. But then there's more operational overhead. Again, we're going to go back now. You have to set up a Zookeeper cluster. You have to set up a Kafka cluster. You have brokers, masters, and it just gets, again, really complicated, really easy. And monoliths have worked since the beginning of the internet. I made my first website. One of the first talks was talking about Angel Fire. On Angel Fire or Fortune City or Homestead or one of these other defunct sites that don't exist anymore. And it was just HTML. It had frames and animated GIFs and stuff like that, but you know, it was the 90s. That's when the web was cool. And I still use iframes. I'm probably the only one, but that's because I learned HTML in the 90s. And it just works. I mean, most of the websites are WordPress, Joomla, Drupal. I mean, most of the university websites are Joomla, I think. Like Harvard, I think it's Joomla. I mean, it works fine. You can scale it out. There's no actual, other than it being PHP, and we won't get into that discussion. That's another day. Most companies don't actually need microservices or the scale, or are never going to get to the scale where you actually need that complexity in your application. Sweet. Oh, see, WordPress. Web server, Apache, Nginx, application, PHP, WordPress, database, MySQL. I mean, that works for 90% of your applications. You could switch out MySQL with NoSQL, Postgres, whatever your flavor of the week is. Databases, I could say the same thing. Do you need sharding? Do you need distributed databases? Probably not. You should probably have backups, and you know, you should have slaves, but do you need like 20,000 shards? Maybe if you're like Elastic, you probably need that, but I don't think so. You still do need some traditional monitoring and logging in your applications because you want to actually be able to debug it when something actually goes wrong. So most actual custom applications you're going to be designing are going to have some kind of business purpose and aren't going to be built on WordPress unless you're one of those companies that builds WordPress plugins and then uses them as your actual website, which I've seen. People do that. You should have CI/CD, even though deploying is actually really, really much easier. One thing I do recommend, though, is to make sure that your monolith is modern. So that means using namespaces, packages, modules, depending on what term your language uses today. Because at that point, you're already thinking ahead in the future if you do have to go down that route, where your actual separation and your boundaries and your contexts are. So when you actually go and have to split out things, you already have the module split out, as long as you're not actually interweaving all your modules with other things. At that point, you should have some sort of shared library. Depending who you ask, it's an anti-pattern with microservices to have like a shared library or a shared service. I've done it, it works fine. It just involves planning and documentation. And I know as developers, everybody sucks at documentation, yeah? We agree? So one of the things I implemented as the principal engineer of a cloud company was an RFC system. That's what built the internet. It is a proven system that works as long as you get everybody to actually, you know, contribute and communicate. It's kind of where DevOps came in with communication failures between all the different teams. And so people make decisions without documenting it and why they made that decision, and then it becomes tribal knowledge, and then 10 years later, somebody wants to know why we did this. There's no trail, how we got there. So I definitely, of all the things on this page, outside of, you know, modular, any system should have an RFC system of, you know, why we made this decision, what this decision serves, and, you know, who it actually impacts. And terminal time. So we did the deployment and the CI/CD pipeline for the microservices. We're going to do the same with the monolith, just so we can see how much simpler and easier and faster it is, so you can see or imagine at your company how fast you can actually take code from development into production. So back to my Jenkins server here. Go over here. Monolith. Build this now. Failed. Sweet. I've had GitHub issues, and it's GitHub issues again, so we'll fix that real quick. Those of you not in ops that have never seen Jenkins, this is what Jenkins looks like. It's not really pretty, but it does the job. So I'm just going to switch out SSH to use HTTPS to actually do the clone. This is using SSH keys to authenticate. It's good. This one's Python, so all it does is install the requirements and run the application in the background to run nose tests against the actual unit tests that I have written for this application. It does not deploy, though, because automatic deployment really wasn't necessary when I looked at it, because you'll see in a minute. So here, we run all our tests. You can see that the application was deleting and posting fine. Delete messages, get notifications, update messages. All that's fine. My tests pass. So it deploys the code. And we do have a key error here, but that's from actually killing the process after it ran. So that's fine. So deploying a monolith, much easier. If you're using modern technology, you can actually take your monolith and you can containerize it, and you can actually run it in a container. So you don't have to worry about your EC2 servers or your Azure virtual machines or whatever you're using. You can just deploy that container wherever you need it to be. Then you just have to worry about your networking. So we will go to monolith. And so we will build it. So yeah, we'll look at it. So this is a Docker file, for those of you that haven't seen it. It's pretty simple. This sets up Nginx, uWhiskey, and MongoDB. As you can see in my comment here, you should probably not put MongoDB in that same container, but for the purpose of the presentation, I cheated. So we have MongoDB in here in all of our configuration. We install our application, and then we have supervisor D, so if one of the components fails in that container, it actually restarts. So now we'll build it. Just going to download layers and stuff. Everybody familiar with Docker? Anybody using Docker in production? Just two? I heard a yeah over here in one hand. Okay. Are you guys afraid of Docker in production? No? So it's more of a political bureaucracy thing. Yeah? Any questions by this builds? No? What was that? I mean, I'm open. Go for it. Yes. I used Cassandra with Kong as a API gateway before ditching Kong, which is an Nginx fork built in Lua, because I had an error that I spent all night reading the source code of Nginx. Don't ever do that. Just rewrite your API gateway and go and just call it a day. But I did this. I found the bug, and I found the bug report for it that was open 3 years ago. And so actually it was OpenResty, which Nginx, same thing. But yeah, Cassandra was the back end where you could actually programmatically register routes and deregister routes and provision how the routing actually occurred. But yeah, not a fan of Cassandra. So we built that, we're going to deploy it, and then we'll be done. And that's how simple monoliths are. And then we can actually talk about scaling it and kind of whatever you guys want, since I guess we have some additional time here. So we have this here. So we're not going to deploy it to Kubernetes because it's probably overkill for a monolithic system. So we'll just deploy it locally like this was a regular server in the cloud. So you probably wouldn't use Docker run. You'd probably use ECS or whatever, the latest, greatest thing is that everybody wants to do. So that Docker is using the Minikube environment. So we'll go over here. and see my local Docker environment. Ah, it didn't run. Oh, actually it did run. I just ran it in the wrong place. So I got to build it again. My apologies. So we have our monolith deployed in, 5 minutes. And you don't have to worry about any of the complexities with that. It's the same way that everybody's been doing work for a very long time. And I mean, my final takeaway here is really, you probably don't need microservices. It's mostly overkill unless you actually work for a large enough corporation where you have that kind of volume and data and traffic. And let's see, I don't know if I have more slides, because again, I'm pretty anti-slide. I did it for your enjoyment. So, any more questions? I mean, I'm willing to talk about anything for Sarah over there that would like to answer or ask me random questions. Other than that, here's my contact information. I'm pretty much open 24/7. I do live in the middle of like 30 acres in Suffolk, so I don't get out here much. But I'm connected 24/7, email. I don't really write on Twitter anymore. I'm not sure if that's a thing, but there's my Twitter handle. I'll get a phone notification. I won't respond. But I do check my email. Cool. But thank you, everybody, for your time. Feel free to reach out.